Hi folks, so let's start with the example or the sample application, which you'll find the detail of the repository as well as detail about the application at the bottom of this YouTube video, as well as you'll get the link of the blog where you can expect much more detail about the application itself. But I would like to have a quick video made for this entire application because the scope of this application as well as the deployment process is bit wider. It has a lot of toolings and the setup itself requires some understanding, and then bit by bit, part by part, you can expect that there will be several other blogs on each of these subjects so that it becomes a comprehensive holistic view of this entire CI/CD pipeline, and then it will try to explain few of the Istio's feature based on the sample application. But before that, I would like to give you a thorough understanding of the various phase, stage, jobs, and pipelines involved, and the logistics and the artifacts involved to create a complete CI/CD pipeline, which is not 100% automated because you will see there are two places where operation needs to do some manual work. It's not like those two particular stage or steps can't be automated. It's basically that's not worth the effort. The message I want to put forward, it's not worth that effort. But anyway, so to start with, mm so the IDE or the tool to make changes, the code, updating the code, I'm using Visual Studio Code, VS Code. My repository is actually a public GitHub. It's not a private one. It's a public GitHub repository. You can see the link at the bottom of this YouTube video where you'll get all the artifacts, all the pipeline files, Jenkins file, as well as all the code, image file, all together. And when you will go through the entire series, one by one, you will understand that what exactly that particular repository, how it's been structured, and where you can find the code, and how exactly you have to deploy uh, those particular applications. So once a person or a developer do some change and push it to GitHub, GitHub actually been configured with a webhook with Jenkins. So that in turn will actually trigger a container build job. Now this container build job basically will build few containers. It will tag it with the Jenkins build number, and then it will push it to the Docker registry. The moment it will be pushed to the Docker registry, a pipeline waiting or listening to the Docker registry changes will trigger. Uh, why it will trigger? Uh, Basically, the trigger been set with any change to the image or any update to a specific image in the Docker registry. So the moment container build job will end and the images been updated to the Docker registry, Spinnaker pipeline will start automatically. Now, this particular pipeline will try to invoke a job, which is again sitting in um, Jenkins server itself, which will try to create a cluster in DigitalOcean cloud. Now, DigitalOcean do Cuddle, their own command line tool, which has a lot of facility over manual creation of the cluster. DigitalOcean do provide managed Kubernetes cluster, and do CTL actually their command line tool. So basically the Jenkins master been configured with do kubectl already, as well as it has kubectl, and it will also use istioctl or istioctl when it will try to deploy istio, but that part will come later and I'll explain at that point of time. So the Jenkins master basically do have this tool, docutl, kubectl, and when it required, it will download and set up istioctl uh, instantly. Now, once the job will create the cluster, Jenkins master will try to save the Kubernetes cluster config file. Again, the docutl command line will help to save the kubeconfig directly from the Kubernetes cluster itself. Now, um, it's a completely secure mechanism because docutl do use API key to have communications with the DigitalOcean API. So um, that's a that's a separate setup, that's a separate steps, which is not very specific to a CI/CD pipeline itself. It's preparations of the Jenkins master in advance, and again that will be discussed in any one of the upcoming lecture or uh, blog. So once that cluster been created, the cluster context needs to be saved, and at on-premise where Spinnaker application server uh, is ready, over there Spinnaker itself needs to be configured with the newly created Kubernetes clusters context, as well as a Spinnaker account or service account needs to be added to the Kubernetes cluster. So there are two things. One, Spinnaker needs to be updated with new cluster config context, so the Spinnaker can talk or speak to newly created cluster, as well as account against which Spinnaker will do all the operations, all the deployment in that newly created cluster. So these two could have been done automatically, but that require a different set of um, architecture altogether. So uh, rather going into that direction, I introduced a manual judgment stage where basically the pipeline will take a pause and wait until operation basically myself update that yes, that particular configuration been done. Again, all the pipeline task been created, that also needs to be updated with that newly created Spinnaker account for that new cluster. Otherwise, none of these deployment will be successful to get deployed in the newly created cluster. So this manual judgment stage will come into picture once the cluster itself will be created, and then it will continue to deploy the SAT Kubernetes SAT manager that basically invoke another job at Jenkins server. Now once that job invoke, it will deploy the SAT manager in Kubernetes cluster. Again, all these stages and all these job will be discussed part by part um, individually. So I'm not going to describe all the steps at once because it is a daunting task to do in one particular session. So now, once that SAT manager been deployed, the pipeline itself will continue to deploy Istio. Now, that actually invoke another job at Jenkins, which will download the latest Istio binaries. It will shed the environment path for Istio kernel command line tool for Istio, and then with the help of that Istio kernel, it will deploy Istio. Now, that Istio deployment, you can use your own manifest file to where you can mention all the settings you need from any of your existing cluster, or for the sake of simplicity, you can simply say, hey, I want to deploy Istio demo profile. I'm actually deploying demo profile, but you are perfectly fine to supply your own manifest file to deploy a highly configured Istio. Now, once that is done, when Istio will deploy, DigitalOcean will start provisioning uh, external load balancer, because Istio will configure ingress, and when DigitalOcean will start provisioning external load balancer, it will also assign a public IP address. So this job, so time to time, DigitalOcean do take at least 2 minutes of time to provision, to complete the provisioning of that external load balancer and to assign the IP. So I'll make this particular job to wait for 2 minutes and then to get that IP address automatically. So this particular job at the end will print out that particular IP address. Now at this moment of time, again, there will be another manual stage where it will ask me to update the DNS with the newly created IP address. Now again, this particular stage also could have been automated, but I'm maintaining my, it's not like a enterprise grade CI/CD pipeline where I do have all my deployment, servers, everything provisions in one particular place. For cost saving scenario, Spinnaker, which is which require a high-end machine with more than 16 gigs of RAM and more than 4 core, which is very expensive. So I'm keeping that Spinnaker server on premises so that I do not need to pay out of pocket to any cloud provider. Basically, Spinnaker and Jenkins together can deploy any applications to any Kubernetes cluster without changing much of your applications. That is why I'm keeping Spinnaker on premises, Jenkins uh, at cloud, and the Kubernetes cluster at cloud. So that is why my domain name server also maintained by another cloud provider, Google. Now, um, now to make uh, uh, that this particular stage automate, I had to go through certain other scripting which I do not have time, and it's not secure. I'll discuss this in another session. But this manual stage to update DNS is a manual stage where once I will get the IP address from this particular deploy to job to deploy Istio, I'll update that IP address to the Google domain. Now, once that has been done, the pipeline will continue to deploy certificate issuer with Let's Encrypt. So basically, uh, this issuer will issue a certificate uh, with the help of Let's Encrypt, and then a certificate object also will be created and deployed. A certificate secret also will be created, and then it will deploy Istio Ingress Gateway, virtual services, and then finally it will deploy sample application. So the Spinnaker application server do have tools like Halyard, HAL basically, to configure and update Spinnaker time to time, then Spinnaker itself and kubectl. So this is the entire uh, overview of these particular